just looking at the effect of vacuum, because I've seen very little discussion by NASA about the effect of vacuum when in space, whether it's at the International Space Station, let alone on the moon. Because the effect of vacuum is quite severe on material manufactured here on Earth, because you get outgassing, not just of water, not just of liquid, but you get outgassing of material, of metals, aluminium, magnesium, and such like.
You need a calculator that actually calculates the force of the vacuum, and here is one.
Because the effect of vacuum is quite severe on material manufactured here on Earth, because you get outgassing, not just of water, not just of liquid, but you get outgassing of material, of metals, aluminium, magnesium, and such like.
You need a calculator that actually calculates the force of the vacuum, and here is one.
Okay.
We're going to select the unit that we're working with, and we're going to come down here, we're going to find the torr in the thing. Right here, we're going to go area, square inches. So now we're into pressure per square inch, so PSI. And that's what people understand. And then the calculated force, we're going to go pound-feet of force. So 760 torr is 1 atmosphere.
That's 14.7 pound per square inch.
Area, we're going to put in 1 square inch. So now you have 760 torr, 1 square inch is 14.69 pounds-feet of. So when you start getting into space, if you have 10 to the minus 1, you have minus 10. That is the amount of force, very little force. 10 to the minus 2, you add 1 more 0, you still have very, very little force coming in there. 10 to the minus 3, which is the edge of space, you now have 19.3 pounds of force per square inch. 1 atmosphere is 14.7, and this is right at the edge of space. When you hit 70 miles up, you are at 10 to the minus 4, and now it's 193 pounds of force per square inch. Now you hit 5, and then we go to 6, and there is the number you're looking at, and that's exactly why the Sandusky chamber has a 150-ton door on it and 10-foot thick walls.
My brain hurts!
Because that's the force of the vacuum inside that it's having to deal with, plus the 1 atmosphere on the outside.
And it's kind of got an eccentric construction, which is part of its history. It was built in the 1960s as a nuclear test facility to test nuclear propulsion systems. And that meant that they built it out of aluminium to make the radiation easier to deal with. Aluminium is not the best thing, the strongest material to build a vacuum chamber out of. So they built an outer concrete skin, which is part radiation shielding and part an external pressure vessel, so that this thing can take the force that's present on the outside when it's pumped out to the conditions of outer space.
You still have to add that one more atmosphere on the outside. But that's exactly showing you the force of the vacuum itself. This is why they can't build a spacesuit today. That's why the Artemis program failed. The physical craft that they're putting up as a capsule just to go, that's only 130 miles off the surface of the Earth, has to be as strong as the Sandusky chamber, because the force is per square inch, so it's based on surface area that you're dealing with. So the Sandusky chamber is 150 feet across inside. It has 10-foot reinforced walls on it. So you have 1 to 15 ratio of it. If you come down to 15 feet across, you still need about a 1 foot thickness of wall to deal with this pressure here at only 130 miles up. When you go out farther, you add one more zero to that, and the number's going to be quite absurd. So this force right here that you're looking at is the limit at which you can use any kind of rubber seals on. After you go past this, you have to use steel on steel. They use silver on copper as a knife edge and carve it in to create the seal. That's how you do it in small chambers in diameter for the vacuum. The thickness of the walls are based on the surface area. So when you take diameter, you're looking at the ratio of 1 to 15. That's how you design a spacecraft. That's why a small tube running through molten glass. When you're 150 feet across, you need 10 feet of walls just to deal with this much pressure. And this calculator is the only one that calculates the force. That is why people need to understand that. Very interesting. But like I said, I've looked at other calculators and it simply failed. This website has for all different kinds of calculations, but it even has weak acceleration. And eventually take away a rock and calculate the acceleration that's based on the electron as well.
That third column, the calculated force, that's measured in how much square inches, isn't it?
There's measurements in the middle. Okay, so its area is 1 square inch. If I change that to square meters, if you like, then you see how big that number gets.
That number is a minus here, isn't it? A negative.
Yeah, because the force scale is tens to the minus.
So that's a minus. So in effect, there is virtually no pressure exerted outwards.
Right. And NASA refuses, or any science people refuse to say that a vacuum has suction or pulse or does anything. They refuse to admit the fact that a vacuum has a force, because they just say there's nothing there, so there is no force. This calculator is showing you in the force scale the force. Yep. It doesn't say it's not a force, and it's not this, and it's not that. It is a force. And if you were to put your hand over something and say, well, it's the area behind it, it's the differential of the two that creates the force. And if there's nothing in space, then there's nothing to have a force against. But when we put a capsule in space and it has an atmosphere inside it, there's going to be a force. And I mean, even the demonstration of people putting a pop can inside a small vacuum chamber, at the very best of pulling 10 to the minus 3. Pop cans are rated at 90 psi. That means you can put them out in the sun and they heat up and they still don't explode, right? You take a pop can that's got 10 or 15 psi in it at room temperature, you put it in a vacuum chamber and it explodes. And they claim that it's only equivalent to 1 atmosphere difference. Because looking at the PSI scale, not the force scale, looking at the PSI scale, so it goes from 14.7 to 0, and anything that's very vacuum. Well, even at this level of torque, you're not at a perfect vacuum.
It was doing in London about 15 years ago. It was 14 times unconventional. So 14 times magazine. And then got Charles Fort, who read also went on anyway. When they started to have conferences, they called it 14 times unconventional. And about 1,000 people in the audience. It was very clear and I was going to talk about conspiracies. That was my word. After I talk, this chap comes up to me, somebody in the audience, and he said, I have a copy of the talk I thought it was all official. So I gave him a copy of it. He said, well, in exchange, you might like this. He gave it to Stephen Murdoch. I said, what's that? He said, Stephen Murdoch. Now, if you remember, a few years ago, some joker managed to wheel out of the NASA headquarters down in Houston the filing cabinet that had all the moon rocks. They got very, very upset and they arrested him. They all the moon rocks back. They said, no, I don't know what I might have is one of the rocks out of that collection. No, I'm saying that's possible. I don't know. I mean, the idea of somebody walking into a Johnson Space Center and wheel out on a trolley, a filing cabinet, that's 6 foot high, weighing about 300 kilos. Never quite sure if any 20 back out. You pretend you're there, it doesn't matter what you have to do. You put on costume, shirt, whatever, you walk around with tools. It's not like you walk around there and it's scary. People come up and watch you what you're doing. And you just, oh, this is all the over and free. And then you question because you got the bulb in your hand, you got tools on, you just go and watch your business. And I think that's probably all the idea. It's funny how people think, it's almost like they think that they took 400,000 people and just pack them all into that 50 acre lot they all in the back and all working there. Yeah, that's what they think. They're all talking to each other. They're all talking to each other. In my talk, I make the point about that. I say, I'm going to have people keep secret. They don't need to. It's actually because if you've got very much to say, like down in California, or over in New York, or also in Florida, or also in Texas, they're thousands of miles apart. How do people get together? It's amazing. You might be in an office with maybe 200 people around you. How working on this? You know what's going on in the office. You don't know what's going on in the board of directors. You know how companies operate. You don't know that. The 3 largest organizations on the planet are the Chinese Army, the Indian Railways, and the National Health Service in Britain. National Health Service in Britain employs about 1.2 million people. Indian Railways employs about 4 million people. Chinese Army is 6 million. Do you really think that every single one of those people in the National Health Service know all the other people are doing? Of course you don't. I don't think they're the idea that 400,000 people suddenly work for Apollo in all various companies. I do have that. It's also said that there are 20,000 companies and a contract for NASA. There are thousands of miles apart. The guys in New York making lander. One talking to the guys in Washington State making rockets. Ask any young person, do you really people around on the moon? They say, no chance. Never happened. Ridiculous. Possibly they thought themselves enough people. Well, they're seeing the complete nonsense going on now in 2022. When NASA are desperately trying to get back to the moon. God's sake, why didn't you 50 years ago?
There is no back to them. There's only 2. If they get there, they will be for the very first time.
But NASA can't admit that. Now, it's probably why NASA is terrible right now. There's all the good engineers that design this stuff. The first space exploration, and they're much more favourable because they're not built until NASA narrative.
Because they haven't done anything about it yet.
No, because they're doing all the way, and NASA know the people. And that's what's
That's why you're quietly saying, oh, we're going to send it down to the private sector. And, like saying that they're 22 billion over budget and stuff like this and that. The delays are